All right, today we're diving into a piece of tech that completely flips the script on how you think about your code. What if you could treat it less like text and more like a giant searchable database? Let's get into it.
I mean, think about this for a second. This question really gets to the core of a huge challenge for, well, pretty much any developer. How do you ask really deep, complex questions about a code base that's maybe millions of lines long, written by tons of different people over years and years?
And that is where CodeQL comes in. It's the answer. See, instead of just seeing your code as a bunch of flat text files, CodeQL treats it as data. It builds this rich, relational database from your source code, which then lets you ask these incredibly precise questions. This is the big idea we're going to unpack.
So, what does it actually mean to query your code? I mean, what kind of questions can you even ask it?
Well, it's really all about finding patterns. So for a security researcher, that might be something like, hey, show me every single place where user input could possibly flow into a database query without being sanitized. Or for a developer, it could be, show me every method that doesn't follow our new error handling rules. You see, you're not just searching for text anymore. You're searching for meaning and relationships inside the code itself.
Okay, so how does CodeQL actually pull this off? It's not magic, right? It's a very logical three-step process. Let's break it down. First up, you have database creation. This is where CodeQL does a deep dive on your code, really understanding its structure and its logic. Then comes query execution, where you use a special language, it's called QL, to ask those questions we were talking about. And finally, in result interpretation, the tool doesn't just spit out a list. No, it highlights the exact findings right back in your source code, which is super helpful. Now, what makes this database so powerful is what's actually inside it. We're not just talking about your text files. It has an abstract syntax tree, which is basically a map of your code's grammar. It's got a data flow graph, which lets you track a piece of data all the way from its source to wherever it gets used. And then there's the control flow graph, which understands every possible path your program could take. It's this deep, deep understanding that gives your queries superpowers. And all of this brings us to what is, honestly, CodeQL's killer feature. This is the thing that makes it so indispensable for security teams: variant analysis. The concept here is so simple, but it's incredibly profound. Once you find a single bug, you don't just fix that one instance. Instead, you write a query that describes the pattern of that bug. You've basically captured its DNA.
And this just illustrates the difference perfectly. The old way, it's like playing whack-a-mole. You fix one bug, and then another one that looks just a little different pops up somewhere else. With variant analysis, you write one query to find and eliminate not just that one bug, but every other bug that shares the same flawed logic across your entire organization. It is a massive leap in efficiency and security.
But here's the thing. CodeQL isn't just about finding security bugs with queries someone else already wrote. Its real power comes alive when you start writing your own custom queries to enforce your team's specific rules and standards. So for example, you could write a query that blocks any new code that's trying to use a vulnerable version of a library, or a query that enforces an architectural rule, like making sure your UI layer never calls the database directly. These are sometimes called architectural fitness functions. Think of them like automated guardrails, making sure your codebase evolves in a healthy, intentional way.
And you can get really sophisticated with this stuff. This query, for example, is calculating a metric called afferent coupling. Now, that's a fancy way of asking how many other parts of the code rely on this one specific piece. By tracking this, you can automatically flag code that's becoming a Jenga tower, too central and risky to change, and prevent those future maintenance nightmares before they even start.
Now, running these queries on your own machine is powerful, but the real game changer is putting this whole thing on autopilot. So let's see how this plugs directly into a developer's daily workflow.
This is where it all comes together. When you integrate CodeQL into your CI pipeline, say with GitHub Actions, these powerful checks run automatically every single time a developer tries to merge new code. It shifts from being a reactive tool you run once in a while to a proactive guardian that's watching over your codebase 24/7.
The GitHub action for CodeQL really just boils down to 3 key steps. The setup step just gets the environment ready to go. The runner is the workhorse. It builds the database and runs all your queries. And then finally, the reporter takes any findings and puts them right in your repository's security tab for everyone to see. The whole process, from analysis to alert, is completely automated. So the big takeaway is this. Your codebase isn't just a pile of instructions for a computer. It's a rich dataset that holds the answers to really critical questions about your security, your code quality, and your architecture. And CodeQL, well, it's the tool that finally lets you ask those questions.
So that leaves just one final thought. Now that you know you can ask your code absolutely anything, what questions will you ask? Thanks for tuning in.